lowering of temperature. So how does this method help us to maintain the supersaturation? Let's see that. So this method involves cooling a saturated solution of a substance to induce crystallization. Okay, as the temperature decreases, the solubility of the solute decreases, leading to supersaturation. This supersaturation drives the formation of crystals. Look at here. Suppose this is the beaker in which there is water. Now, if we put sodium chloride or table salt in it and make a supersaturated solution, and after that, if we slowly cool the solution, then what will happen? Crystal will start to form, and with slow cooling, the crystal size will start to grow. And if we keep decreasing the temperature, the remaining crystals, the remaining sodium chloride, will always form a supersaturated solution. That means if we don't decrease the temperature rapidly, then the supersaturation will be kept maintaining. Okay, this is the case. The temperature should be decreased slowly. This supersaturation drives the formation of crystal. So only condition is temperature decreasing decreasing slowly, because temperature and solubility are interconnected, right? If temperature increases, solubility increases. If temperature decreases, solubility decreases, and as a result of that, slow cooling will help to maintain the supersaturation. Now, so what is the procedure of this method? That is lowering of temperature method. Let's see that. So the procedure involves different steps. The first step is preparation of saturated solution. So here, dissolve the solute in a suitable solvent at a temperature above its saturation point. Ensure the solution is clear and free from impurities. That is the condition. Now, the next step is controlled cooling. So it should be cooled controllably, okay, with controlled environment. Look at here. Slowly reduce the temperature of the solution, often using a temperature controlled water bath or oven. So the temperature should be reduced slowly. A slow cooling rate allows for for the formation of larger and more perfect crystal. The third one is crystal nucleation and growth. This is These two methods are very important. Okay, nucleation and growth. So as the solution cools, nuclei form. So with decreasing the solution, nuclei forms. Okay, nuclei forms, acting as starting point for the crystal growth. The rate of cooling influences the number and size of nuclei. So we have already talked about that. Slow cooling will make less number of crystal but larger crystals. But rapid cooling will make more number of crystals but smaller crystals. Okay, slower cooling generally leads to fewer but larger crystals. Now, crystal selection and harvesting, that is the fourth step. So here, once the desired crystal size is achieved, the solution is carefully cooled to room temperature. Okay, the crystals are then filtered, washed and dried. So this is the procedure for lowering of temperature method to grow a crystal. Now, there are certain advantages and disadvantages. They are simplicity. This method is very simple. Versatility and control over crystal size and shape. Okay, these are different advantages. Now, disadvantages are slow growth rate, risk of impurities, and difficulty in controlling nucleation. You can just pause the video and read this. These are very simple points. You can easily understand it. Okay. Now, similarly, there are certain application of this method. They are growing single crystals for research. So this method is very useful for growing single crystals for research in physics, chemistry, material science, etc. Similarly, industrial production of crystals, that is when crystals should be produced in industry, this method is very useful method for that. Now, additional considerations can be taken as seed crystal. So introducing a small seed crystal can accelerate the growth and improve crystal quality, that is impurity adding. Now, solution purity. High purity solvents and solutes are essential for obtaining high quality crystal. Now, temperature control. Precise temperature control is crucial for optimal crystal growth. So, these are some of the additional considerations that should be taken. So, I hope you understood about this method.